We're looking at, this is the AP exam review worksheet 1. Uh, we're looking at topics dealing with definite integrals. So these application problems have shown up in previous AP exams, these density problems. So I want to make sure to go through these with you. Density, first off, is a material's density is its mass per unit volume. In practice, we tend to use units we can conveniently measure. Population density measured in units like people per mile along the edge of a road, or people per unit area in a city, or bacteria per cubic centimeters in the test tube. These are the popular problem sets that we've seen. Okay, we're going to be interested in problems that do not have um, constant density. One of the easiest scenarios to think about maybe is how more people live closer to cities. If you had a function telling your density, telling you that population density as a function of a distance from a city, you'd expect the density of people to decrease as you get further out away from the city. That's just how people live. Let's look at the problem that will take a little bit of calculus to solve. So, example 1 here. A city located beside a river has a rectangular boundary as shown in the figure. So here, this is the dimensions of a city. Population density of a city at any point along the strip x miles from the river's edge is f of x persons per square mile. Which of the following expressions give the population of the city? So what we need to do is we need to, first off, we're going to identify this rectangular area strip. So we're going to represent this rectangular area strip has a height as 7 miles and a width of, let's call this delta x. So delta x represents the width of this particular strip of land. So the area of the strip, okay, which in this case is 7 times delta x, multiplied by the number of people in the area. Okay, so we multiply by f of x, which is the population density of f of x in people per mile squared. Okay, so if we do that, then we give it, we're basically going to be accumulating these rectangular strips over the course of this, from one end of the town to the other. So from one end of the town, it's 0 miles from the river all the way to 4 miles from the river. So that's what the bounds are going to show. The bounds are going to show from one end to the next, and then we're accumulating the area of this area strip. And this area strip here is going to be 7 dx. Well, we convert delta x to dx times f of x. So 7 dx gives us the area of the strip, and we multiply it by the number of people in the area, the population density, and people per mile squared, and then that's how we arrive at our solution. So we take the integral from one end of the town to the other, 0 to 4, and then 7 dx f of x, we're accumulating these infinitely small strips from one end to the other end. Right? So the setup is going to be 7 definite integral from 0 to 4 f of x dx, which matches choice B. Okay. Example 2, a city is built around a circular lake that has a radius of 1 mile. Okay. So here's the lake. Okay, from the center of the lake to the shore of the lake is going to be a radius of 1 mile. The population density of city is f of r per people per square mile, where r is the distance from the center of the lake in miles. Which of the following expression gives the number of people who live within 1 mile of the lake? So within 1 mile of the lake, it'll be from 1 mile out to 2 miles out, right? Because no one is going to be able to live from 0 mile to 1 mile, because this is on water. And then from 1 mile to 2 mile, this is going to be the radius where people will live, or this is going to be the land that we're concerned about here. So what we're going to do is we're going to add infinite circumference strips from 1 mile to 2 miles. So if we take one of these strips, okay, one of these circular strips, and if we were to cut it, and if we were to unfold it into a rectangular strip, what's going to happen is we know the distance around a circle is going to be 2 pi r, right? 2 pi r is the circumference, and then the width of that particular strip will be delta r. And if we take the area of this and we multiply by f of r, then we have the population density for this particular strip. Okay, so area of the strip is 2 pi r times delta r. 2 pi r times delta r. We can convert delta r to dr times f of r. So all this represents the population for this particular strip. But we're going to add infinite strips from 1 mile out all the way to 2 miles out. So from 1 to 2 miles, we're going to take this number of people who are living within this area here, and then we're going to accumulate that from a radius of 1 mile out to 2 miles. So integral from 1 to 2, 2 pi r dr f of r. And if we clean this up a little bit, we can make it match one of the answer choices, which is 2 pi, definite integral from 1 to 2, r f of r dr. That'll be answer choice D.